Hello all. This video is all about understanding the program development of a typical C program. The typical C program has two stages. One is editing stage of a C program and the post editing stage of a C program. The editing stage, prior to the editing stage of a C program, we have to have the purpose of writing a program, which is a problem on hand. We need to have an algorithm for the problem, and once the algorithm is developed, the algorithm is verified for its correctness and other properties. Then you write the C program, and once you write the C program has to be entered into the machine by using a program gedit, since I am using Ubuntu. So currently what I am doing is I am doing the editing stage of a program. So what is the normal procedure that is followed in all the reputed books concerning C programming is they ask us to write the first instruction as hash include stdio.h int main open bracket close bracket 2 flower brackets, the very infamous hello world. So the problem on hand was we wanted to make the machine tell us hello world when we execute the program. So I have just assumed myself to know the structure of a typical C program. I enter the code and then I save the program in a file called a.c. So once I save the program in a.c, so my editing phase is now over. After that I will have to do the post editing phase. The post editing stage of a C program typically include the pre-processing, the compiling and assembling, and executing the C program. So let me just show you all the three stages of this typical C program. To do that, I open the terminal and I call the GCC compiler or the GCC system. If I want to know the version of the GCC system, I type GCC -- version. So the current version of the GCC that I am using is GCC version 4.8.4. Now our job is to ask the GCC to generate, to pre-process the program and put the output of the preprocessor into an output file called pop.c when I pre-process a.c. So when I do that, the preprocessor now generates the output of after acting upon a.c, and the same program is put in pop.c. Then I submit the pop.c that is generated to the compiler by giving a switch called -s, which is compile only, assemble and do not link. Now after I did that, if I now list all the files that is related to a.star, if you can see, now this is my a.c file, okay, and then as you can see I put the file of my preprocessor output onto a file called pop.c, which is the preprocessor output. So now I no longer require my original file called a.c, which when I submitted to GCC using the -s switch, I get this file called pop.s, which is the compile only file. After I do that, I submit this pop.s file to the GCC using a minus switch, which indicates compile, assemble, but do not link. So when I do that, if I now list all my pop.dot files, you could actually see this is my pop.c, which is the preprocessor output generated by the GCC after acting upon a.c. Then we generated pop.s, which is the compile only option on pop.c, and this is the pop.o. And now I ask the GCC to link this file pop.o and generate the linked binary image of the file. So when I do that, now my binary image of the file is actually stored in a.out. So when I type a.out, I get the hello world program. So if you go back and want to find out what all each of these files actually contain, if I look at my pop.c, my pop.c contains the entire preprocessor output that is generated, and this is my preprocessed file, if you can see. And then if I now open the compiled only file of a.c, so I should get pop.s, sorry, this is pop.s. So this is my compiled only, okay, file of my hello world. And then if I now go back and open the file of my pop.o, which is the compiled and assembled but not linked file, I will not be able to see anything because this is completely cryptic. And that's how I execute all my programs. So let us go back again. So I submitted my a.c file to the GCC using minus it generated pop.c. So I took the pop.c and then gave the input to, if you see, compile only option by giving minus s. It generated pop.s. You can see the compile only option, compile only version of my pop.c, which represents a.c, and then it generated pop.o, and finally I was able to generate the output when I say a.out.